number 11 from the Finney textbook, and this is tangents at a point, and they gave us this function y equals 1 over x minus 1. So I've just drawn the function here. I've got my vertical asymptote at 1. Okay, it's a reciprocal function, or a rational function, so it has an asymptote going down to 0. And we're being asked to evaluate the tangent at the point x equals 2. So there's my black dot at x equals 2. When I plug 2 in, I get y equals 1. So I'm going to choose a point arbitrarily close. We're going to call that point x2 plus h. So that's the coordinate in red. And the y coordinate would then be, I plug in the 2 plus h in for x, and I end up with 2 plus h minus 1, which we could simplify to 1 plus h. Okay, and so we have now 2 points which we can make our slope. So I'm just going to make my slope triangle here, and I'm going to apply a limit here because I want to let the run be equal to 0. So this value here between 2 and 2 plus h is going to be h. Okay, so we're going to let the limit as h goes to 0 of the rise, which is going to be 1 over 2 plus h minus 1 minus 1 over 1, which is, we'll just leave that as 1, all over 2 plus h minus the coordinate of 2. And this always simplifies to just h in the denominator. So we end up with h in the denominator. And I end up with 1 over 1 plus h minus 1. Okay, so I need to simplify this algebraically so I can get rid of the divide by h. So I get limit as h approaches 0. And to do this, I'm going to add the numerator together. Okay, so I need a common denominator. So I get 1 plus h minus 1 I'm going to express as 1 plus h over 1 plus h, just so that we're clear on where these pieces are coming from. That minus 1 is same as that. Okay, and then instead of having a complex fraction, I'm just going to put that h in the denominator down here. So just so that, again, so that you see where everything is coming from, that's where that h comes from there. Okay, so at this point, I'm going to continue. And I can see that if I add this together or subtract it, the 1's cancel out. And be careful because this is minus 1 minus plus h. So it's going to be minus h in the numerator. And we have a common denominator of h plus 1. And then we're going to divide by h. Those h's cancel out. So I end up with the limit as h approaches 0. And this is what we really wanted. We wanted to get rid of this 0 divided by 0, okay, because that's what we're trying to get rid of. And we end up with negative 1 over 1 plus h. And as I let h go to 0, I end up with a slope of negative 1. So what that's telling me then is that tangent slope through that point is going to have a slope of negative 1. Okay, so that's what this limit has told us, is that as we bring that point closer and closer, and we're calculating the slope ratio, that ratio simplifies to about negative 1.